Any others? Allison? 3. 2, 3. Any others? Yeah. 4.
15.
Alright, so starting with 2, you may remember this, you may not from algebra. When it's asking if this is a function, it's asking if you're looking at the ordered pairs and you're looking at the x values, you're trying to see do any repeat, and if they repeat, do they go to different y values? If they go to 2 different y values, then it is not a function. Also, if you plotted these points like on a graph and did the vertical line tests, it would touch both of these points at the -1 line. So it would also not be a function. 3 is just rewriting this into math. So 3 times the difference. So I'm multiplying 3 to all of this. So I'm going to put this next part in parentheses. Difference is subtracting. So a number, pick whatever variable you want, and 7. Is going to be equals, and then 18. So it doesn't say to solve it, so we just needed to set up the equation, not solve it. Questions on those 2? And then 4. So 4 you may recognize as a systems equation because the Buffalo Bills scored 24, more than twice the number of points Miami Dolphins scored. And altogether, the team scored 66 points. So we're going to have 2 equations. Variables, I'm going to say B and M for points scored by both. And then one of our equations, all together, they scored 66 points, so we'd be adding B and M. The other one, the Buffalo Bills scored 24, more than twice the number of points. So if we knew the number of points Miami Dolphins had, and we multiplied it by 2 and added 24 to it, we would get Buffalo Bills. So this is going to be a B equals equation. And then 24 plus 2M. Thinking back to how we saw systems, elimination, graphing, substitution. Substitution would work really well with this one because we have a B equals and we have a B. So I'm going to replace this with B. And say 24 plus 2M plus M equals 66. Now we can solve for M and then go back and solve for B. Subtract 24. We have 3M equals 42. M equals 14, I believe. Then go back, take that M equals, put it in for B. I'm sorry, put it in for M, solve for B. In either of these equations, does not matter which one. So 52 points and 14 points would be our final answers. So I know we don't do the short bites often, but as we do them throughout the year, it's supposed to be good practice to help you remember past things that we've either talked about or things that you've seen in previous classes. Questions on that? Before we get into lesson stuff, I wanted to say a couple things. One, as I said earlier, I passed out grades to you. One is your marking period 2 grade. The other is your year grade. The last test we took, the Unit 4 inequalities and those Khan Academies, those were the last grades I was putting in for marking period 2. So whatever you have now will be your grade for marking period 2 unless you do Khan Academies. So keep that in mind. If you need to retake Unit 2B, Unit 3, or Unit 4, come see me or Miss Larson to do that retake process, get that done as soon as possible. We'll do more grades and then go back to quarter 2. The year grade, if you're looking at that right now and it's not a passing grade, you need to either do something to bring your marking period 2 grade up, or is really an and or. Next 2 quarters, you're going to have to work even harder to make sure that that is a passing grade. So I would say make sure this quarter is a good grade to go into your year grade, but also if it is not currently a passing grade, you're going to have to work really hard to make sure that it is a passing grade by the end of the year for the next 2 quarters. So keep that in mind moving forward. The end of this marking period is the 27th, which is a Friday. The last day I'm taking missing assignments, retakes, tests you need to finish is the 26th. So that Thursday, what I do not want you to do is wait until that Thursday to do retakes and missing assignments and tests. Please come see me before then. As you'll see and we'll talk about in a second, we'll have flex days in between then. Come see me before or after school. If all of you wait until that Thursday, I'm going to have 120 students in here trying to all do the same thing, and I don't want that. So make sure you come get that done as soon as possible. Do not wait until then. Questions on that before we talk about other schedule stuff? So look at your course calendar. There's just a couple things I want to point out. One, there are only 2 Khan Academy due dates, this Friday and next Friday. There are only 4 Khan Academy quizzes for this unit, and 3 of them are related to what we are going to do today. So make sure you get those done. This unit will be 3 objectives, and each day will depend on what we get done. There are 2 flex days. One is an actual flex day. The other is more a review day that you can also use as a flex day. So the 17th and the 25th. So if you need to retake, again, don't wait until those days. Try to get them done before or after school before that. But if you need to do it either of those days, you have those days as well. And then your quiz is the 19th. Your test will be the Monday we come back from that, unless there's any snow days in between that. Questions on any of those? As always, all those dates are also in Canvas, so if you lose this, they're there. And then also, as always, for every unit, if last unit you didn't do that well, or maybe you weren't really paying attention, you were on your phone, you were sleeping, just try to do better this unit. Try not to do those things. Moving forward, ask more questions, pay attention, stuff like that. Alright, we're not going to do a whole lot of starting before lunch, but I'm just going to briefly talk about this and give you this definition. So everyone should have these notes. So this unit we're about to start is on variation. A lot of relationships, how things relate to each other, kind of like proportions, but not also. So the first type of variation is direct. Direct variation is a specific relationship in which there is a constant ratio between all ordered pairs there's a specific equation we're going to use for direct variation, and it's written in the form y equals kx, kind of like our slope-intercept form equation, but not because we're using k instead of m, but they kind of work the same. And then, as we're using this equation, the k is your constant. You'll hear or see it be called constant of variation, constant of proportionality, interchangeable. The way we find our constant k is y over x. And that didn't just come out of nowhere. It really comes from the original, so I'm going to show you where that comes from. So if I had my original and I was solving it for k, I would be dividing both sides by x, which is how we get the y over x. So if you ever forget how do we solve for k, go back to the original and solve it. Right? So we're not going to get into the problems until after lunch. I just wanted you to have that piece of information. So we talked about the equations. We're going to use at least one of these equations to actually find k. So whether you're given ordered pairs or a table, we're going to be using the k equals y over x. And we're going to do that and see if we get the same k value for each of the ordered pairs or each values in the table. If it's the same throughout, then that is your k value. We can find our equation. If it's not, then that's not our k value. We wouldn't find our equation. So starting with number 1, we would divide y over x for each one. Simplify it. So 4 over 1 gives us 4. 8 over 2 gives us 4. 12 over 3 gives us 4. And 16 over 4 also gives us 4. So it's the same. So because it's the same, we can say that our k value is 4. And then because we have a k value, we can write our equation. Y equals 4x. Questions about that so far?
So will the numbers always be even, or is there also going to be decimals?
There could be fractions.
Okay.
We want to leave them as fractions instead of decimals, but if it's a nice decimal, then we can put it as a decimal. So it could be even, odd, or I should say, it could be integer, it could be negative, could be fraction, it could be a bunch of different things. Okay, let's try another one. Like number 3, do the same thing, find your k values across, but y divided by x for each one. So we have negative 8 over negative 12. Simplify them. So negative or positive 2/3. Negative 4 over 6 over negative 6, which would also be 2/3. 0 over 0 wouldn't work, but we're going to come back to that. And then 2 over 3 would work. In general, if you saw something like this, where you got 3 of the same thing and then the other one, you would probably assume this is not direct, so you wouldn't move forward. But if, because I said this equation is very similar to our slope-intercept, y equals mx plus b, if I asked you to think about your b value, what is your b value here? That would be like m. K is like m, y and x are in their right place. What would our b value be? most likely be out here. Let's revise. Is there a b value out here right now? Not one we can see, but we would assume it to be 0. The same thing can be said about everything else. For direct variations, our b value, our y-intercept, has to be 0. So if you see the ordered pair 0, 0, either in your ordered pairs or in your table, even though that constant finding the k would not work, it still goes through 0, 0, so that still works. Like if you graphed all of these points, it would go through the origin or 0, 0, and if you counted your slope or your k through all of the points, it would still be the same. So even though this value is not the same, this is still a direct variation where k is still 2/3. So your equation would be y equals 2/3 x. So questions like that might trip you up because you see the zeros and it wouldn't give you the same k value, but you just have to remember it goes through 0, 0, so it would be a direct variation. Questions on that? So not only do we need to be able to find the k value, but we also need to be able to look at equations and graphs and see, are these direct variation equations or graphs or not? So if you need to rewrite that equation down here, you can. Y equals kx. And we're looking to see that, do these equations match this donut? Is 5 a direct variation based on that format? Does it have a y, a k value, and an x? Yes. So this would be direct variation, and we would say our k value is the number in front of x for this group. What about 6? Yes. They look similar, even though it's negative, even though it's a fraction, same thing. This would still be a direct variation. Our k value would be the negative 4/5. What about 7? Right here. Yes, I see some no's. Why no? There's no x. So it's not a direct variation because there's no x. So we don't have to find the k. For 8, we would need to solve it first. So divide both sides by 2. So we have y equals 5x over 2 or y equals 5 over 2x. So because you can write it either way, that would be. What about 9? Would that one be? No. Why not? There is, it's just invisible. But that's not why it makes it not a direct variation. There's something else. Because it has a different b that's not 0. So direct variation has to have some number for your x in front of your x, for your k, and then it has to go through 0, 0. If it does not go through 0, 0, or it has a b that is not 0, it is not a direct variation. Right? We'll come back to any others that we want to see or go over in a moment. But before we do that, do we have any questions on how to determine if an equation is direct or not? If not, go on to the next page. For your graphs, they kind of take what we talked about already. It has to have the same k value between all of the points, kind of like your slope, and then it has to go through the origin. Does 14 do both of those things? Yes. It goes to the origin, definitely. If I'm counting up and over, this is 3 over 2, 3 over 2, so that value stays the same. So this would be a direct variation. If we wanted to take this a step further and write the actual direct variation equation, we could say y equals 3 over 2x, but it didn't ask us for that. Does 15 do both of those things? Does it go through the origin and have the same k value? It doesn't go through the origin, but does have the same k value, so no, this is not a direct variation. So as long as you can recognize with an equation and with a graph, is it direct or not, then you're good. Questions on those? Then there is a piece where you're going to be given two sets of ordered pairs or something like it, and you're going to have to find one of the missing values. So this is really where those equations that we talked about before come into play. So if you want to rewrite them, you can. Y equals kx and k equals y over x. If at any point you forget what those are, they're also on the vocab wall. So with these, focus on what you're given together first. Ignore the missing piece. So we have 2 and -4. We're going to start at 18. We can find our k value first, and you should for each of these problems. So divide -4 and 2 to get your k value. After we get that k value, we're going to put it into our direct variation equation. Y equals, our k is -2, and then x. Then you can look at the missing piece and put whatever you have in there. So we have x. Put that in, figure out what your y is. A good check for these problems, for all of these problems, is to go back and see, does your k value still work here? So if I take 12 and -6 and I divide them, I should get the same k value. If you don't, something might be wrong with your work, so double check that, because you should get the same k value. So because these are the same, that works. 12 is my final answer. Before we move on, what questions do we have on that one? All right. And we're going to do another one too. So the very first thing we need to do for any of these is find k. So divide y and x together. Figure out what that is. After you find that, take your direct variation equation, but instead of writing k, write the number you just found. Then look at the last set of ordered pairs, put in whatever you have, and solve for the other one. So we have x, and then we can multiply those to find y. Then this last part, blue, is just to check yourself. Did you do it correctly? take the number you found. Well, take whatever you're finding and then whatever you were given, divide those together. You may be solving for x, you may be solving for y, it depends. Divide those and see if you get the same k value. If you did, then your answer is fine. If you didn't, something's wrong, and you've got to go back and check your work. Okay, let's try one more. One more of these types, I should say. So let's do 19. Okay. Start the same way. The numbers you have, find your k. So 16 divided by 4. Take that k value, put it in your equation. Y equals 4x. Look at what you're given. Now you're given y, and you don't know what x is, so put 24 in for y, and solve for x. Divide both sides by 4. And then even though we solve for a different thing, the check still works here. So if I take the 24 we were given and the 60 found and divide them, we still get 4, which was our k value, which works. So we know we did that right. Questions on that one? These ones down here that have words are really the same thing. They're just in word format now. So we're going to do 22. Think about the first two numbers you're given as like the ordered pair. You would know both x and y. So if y equals negative 18 when x is 3, focus on just that part first. So of these two, I'm going to divide them to find k. Negative 18 divided by 3. Take that number, put it into the equation. Then look at the second part. Find x when y equals 30. So we know y, we don't know x, put 30 in for y. Solve for x. Divide both sides by negative 6 so that x equals negative 5. Again, you can still do the check to see if it works. So y was 30, x is negative 5. We divide those, we get negative 6, which was our k value, so that works. Do you have any questions on that one? And then we're going to do one more of these and then move on. Let's do 24. Same as before, same process. Find your k value, 10 and negative 4. Simplify that. So that would give you negative 5 over 2. So our k value is going to be a fraction. So y equals negative 5 over 2x would be our direct variation equation. In the second part, find y when x is 12. We don't know y, but we know x is 12. Put 12 in for x. Someone multiply that. Tell me what you get. negative 30. And then especially when you get like bigger numbers than you might see, definitely double check yourself just to make sure, did I get the right answer? Did I get the right work? Did I do this correctly? So negative 30 divided by 12. We simplify that, divide both by 6, we get negative 5, which is our k-value, so that works. So really, as long as you know your two equations and how to use them, you can do all of these problems. There are some word problems that go along with this, but before we get to that, look back at any problems that we didn't do on this page, on the last page. Are there any you want to see, go over, had questions about? Aaron. 11. So he is still writing this down. Right, 11. Here we would need to solve this for y, get y by itself. So divide both sides by 2. Is this a direct variation? And remember that we can rewrite this. This is the same thing as 1/2 x. So then yes. So if you see x in the top, just move it to the side, put 1 in its place, and then yes, it would be. Where k is 1/2. Any others who want to see, go over, have questions about before we move on to the word problems? If not, find this page. Ignore that part. You'll see that when we get on to inverse. So there's a few nice things about these problems. Is that one, it'll tell you whether you're dealing with direct or inverse. Of course, we haven't talked about inverse yet, but it'll say something like varies directly, proportional, something like that, so you don't have to like guess. So that's good to know. But also, when we're using direct, things that you should be aware of is that whatever they're talking about, they usually either go up together or go down together. So what I mean by that is the more people that attend a game, the more sales that game makes. The less people that attend a game, the less sales the game makes. The more time you use to study, usually the better your grade is. The less time you use to study, usually the lower your grade is. Things like that. They go up or down together. What's a couple other things that are really nice about these problems is the missing value problems we were just doing. These are set up just like them, except there's just more words. So we just have to figure out what pieces we're missing, what we're solving for, and the process is the same. So we don't have to learn a whole new process on how to solve them. When we start to read these, whatever comes before the words very directly proportional, when we get to inverse, whatever comes first, that's always going to be your y. And then whatever comes after those words will always be your x. So that's also nice because we don't have to guess at which one it is. You will need to be able to know which one are which, either by labeling them here or writing them off to the side, which I'm going to do both. So Y would be like the sales, X would be the number of people. Okay. And then just like the missing value problem, take it one step at a time. Focus on the things you know, find K, and then go on from there. So if the sales for a game are 12,000, so that would be your Y. When 800 people attend, that would be your X. So stop there, look at those two numbers. Let's use them to find K. So K would still be your Y over X if you need to rewrite those equations somewhere. Y equals Kx and K equals Y over X. So if we do our Y over X, that would be 12,000 over 800. Someone do that. Tell me what you get. 15. And because our K here kind of represents, slope, we can really write this as whatever Y was over whatever X was. So 15 would represent dollars per person. This is not a necessary step, but so you understand what this K value is doing here, not an inverse. So we have our K value. Just like before, we're going to put this into our equation. Y equals 15x. Look at the second part. The hardest part about these is figuring out what you're trying to solve for. So here, we need to find how many people attend if the sales for a game are 15,000. What are we solving for? X or Y? X. So this would be 15,000 equals 15x, and solve for X. How many people attended? 1,000. And then because these are word problems, be specific, 1,000 people. I shorten people because I don't have space. The check method works the same here. You can still do that to make sure that you solve for the right thing. Because if you solve for the wrong thing, your K value won't work here. So we had 15,000 for our Y, 1,000 for our X, which gives us 15, which was our K, so that works. So again, the check is not necessary, but it is there to help you. Before we continue, what questions do we have on that process? Let's try another. Number 2, your ounces of medication, that comes first, so that's your Y. Vary directly with the weight of a patient, that comes after, so that's going to be your X. I'm going to write that off to the side. This LV. If a 120-pound adult requires 3/4 of an ounce of medication, so the 120 pounds would be our X. The 3/4 of an ounce would be our Y. So we're going to find our k, but we don't want to write the 3/4 as a fraction because we're already dividing. So we can change that to a decimal. So we can say 0.75 over 120. Figure out what our k value is. It will be a decimal. Mm-hmm. 0.00625 was the correct k value. And again, just like before, this would represent ounces per pound. The slash and this is the per. So then we can put that into our equation. Y equals 0.00625x. And we're looking for how many ounces are required for a 200-pound adult. What are we looking for? Y or x? Y. So we don't know y, but we know x, so we can put 200 in for x. Multiply that and figure out what y is. .25 what? Ounces.
I would be terrified of that word.
Imagine taking 1.25 pounds of medicine. Okay. Really quickly, especially because we have a lot of decimals, definitely double check your work. Because you may have missed a decimal or put too many by accident. If we do 1.25 over 200, we should get 0.00625. Someone do that and see if we get the same thing. Yes. Do we have any questions on that one? We're going to do one more of these. Number 5. Anyone still writing this down first? For number 5, the income of a computer analyst varies directly, so the income will be our Y. Varies directly as the number of hours worked, so that will be our X. If the analyst earns $256, so that would be their income, for working 8 hours. So let's find our K value using those numbers. 256 over 8 would give us what? And if we're putting the label of what our Y and X are. Income was dollars per hour. The question then says find the constant of variation, which is what we just did. So we don't have to do anything else. This was our answer. So make sure as you read through these problems that you do exactly what it says, but don't do more than what it says, but also don't do less than what it says. Questions on that one? Are there any on this page, on any other page, the practice pages that we want to see, go over, have questions about before we let you guys practice? If not, there are the problems we did not do. There's like 3 pages connected to that of practice. There are also, the 2 Khan Academies that are due this week. Constant of proportionality from equations, and so that's finding your k-value from the equation, and proportional relationships from graphs, being able to determine which ones are direct or not from a graph. So you can work on those, you can work on practice from this. Just use this time wisely. Let us know if you have any questions.